In this screencast, I'm going to talk to you all about graphing polar functions, which is a little bit trickier than graphing rectangular functions. First of all, theta is your independent variable. You're going to plug in values for theta. You're going to get out values for y. So y is your dependent, theta is your independent. Okay, so we're going to look at the function r equals 4 cosine theta. And when theta equals 0, cosine is 1. 1 times 4 is 4. So when I'm facing in the 0 direction, I'm going to go out 1, 2, 3, 4 and put a point. Okay? Now pi over 4. Cosine of pi over 4 is root 2 over 2. Times 4 would be 2 root 2. So that's about 2.8. Okay, so I'm going to go out facing the pi over 4 direction along here. I'm going to go out 1, 2, and a little bit less than 3. Then I'm going to connect those points with a kind of a nice smooth curve. Okay, cosine of pi over 2 is 0. Times 4 is still 0. Cosine of 3 pi over 4, that is negative root 2 over 2. So when I'm facing in 3 pi over 4 direction, I'm going to step backwards negative 1, negative 2, negative 2.8, right about there. Okay, so I've gone down to 0, and now I've gone back to negative 2.8. At pi, cosine is negative 1. 4 times negative 1 is negative 4. So if I'm facing in pi direction, I'm going to go backwards. I'm going to hit that point again, so I'm repeating myself. Cosine of 3 pi over 2 is 0. Times 4 is still 0. And cosine of 2 pi is 1. Times 4 is 4. Now you may notice that we have some symmetry here. And so if I'd only gone from 0 to pi, I would have gotten all I needed. You can also use your calculator to graph this, but I need to point out some important things you need to do first. When you go to mode, make sure you're in radian mode, and make sure you are in polar mode, POL. When I get into polar mode, that means when I hit the xt theta n button, I will get a theta instead of an x. So we're going to graph 6 sine theta. When I hit my y equals button, now it's r equals, and I hit 6 sine theta. When I go to window, usually having theta start at 0 and end at 2 pi is going to be enough. Sometimes you need to do a little bit more. Sometimes you need to have some negative theta values, but usually 0 to 2 pi is going to be enough. X min, X max, Y min, Y max, those are all like normal. When I graph it, I get what looks like an ellipse, and this is really important. When you're graphing polar graphs on your calculator, you want to do zoom 5, which squares it up, and then you get a true representation of what your graph looks like. And we can see that this is actually a circle with symmetry on the y-axis. And let me grab our polar equation there. Okay, so don't forget to do z-square if you're using your calculator, so you get a good, accurate representation of what the function's doing. Okay, so we've talked a little bit about symmetry. You can have 3 kinds of symmetry with polar graphs. You can have symmetry over the line theta equals pi over 2. And so what that means is if I have a point out here at r theta, then I'm going to have an exact reflection of it over here, and that's going to be at r comma pi minus theta. Or you could also get there by going negative r, negative theta. If I have symmetry over the polar axis, that means that if I'm out here at a point r comma theta, I will have an exact mirror of it down here, and that's going to be at r comma negative theta, or negative r comma pi minus theta. So to test for these different symmetries, you replace your r with, say, negative r, and you replace your theta with pi minus theta, and see if your polar equation is the same thing. Okay, symmetry about the pole. Here's my original point, r theta. I'm going to get a reflection of it down here at negative r theta, or r comma pi plus theta. So those are the three symmetries to look for when you're dealing with polar graphs. So let's use symmetry to make our life a little bit easier. I'm going to look at the polar equation 2 plus cosine theta equals r. I'm going to replace r with r. I'm going to replace theta with negative theta. And you may remember that the cosine of negative theta is exactly the same as the cosine of positive theta. So nothing changes, so we have that kind of symmetry. Well, which symmetry gives us r negative theta? It's symmetry over the polar axis, which means I only need to worry about graphing the top half, and I'm going to match it with the bottom half. So here we go. I left off 0, so let's go ahead and do that. 2 plus the cosine of 0 is going to give me 3. When I go to pi over 6, that's out here. I'm going to go 2.9. 2.7 when I'm going along pi over 4. 2.5 at pi over 3. At pi over 2, I go exactly 2. So far, we've been doing this. Okay, 2 pi over 3 will put me at 1.5. So we're getting closer to the origin, aren't we? 3 pi over 4, that will put me at 1.3. Hang on a minute. I think I skipped over a point there, didn't I? Okay, so we were at pi over 2. We were at 2. Yeah, here we go. This is 2 pi over 3, so I'm at 1.5. 3 pi over 4 is along here. That's going to put me at 1.29. I'm just estimating here, guys. 5 pi over 6 is right here. That's a little bit more than 1. And finally at pi, I'm at exactly 1. So we're curling in like that. Then we use symmetry to make a curl. Well, not quite like that. Went a little bit too far, didn't I? We use symmetry to match it. This is called a cardioid. It's one of the special kinds of polar graphs we're going to talk about in my next screencast. Meanwhile, now you know the basics of how to graph a polar equation by hand.